get started. Given standard form, find the y-intercept of the quadratic function below. So the y-intercept is where it crosses the y-axis. Sometimes it's good to like draw it as, all right, there's x, there's y. What's going on at the y-axis? Oh yeah, it's when x is 0. So the y-intercept is like finding f of 0, putting
Okay.
0 in for x. Okay, so wherever you see a 0, you're putting, or wherever you see an x, you're putting 0 in. Then you just have to evaluate, order of operations here. So first you're going to square 0 squared is 0. 2 times 0 is 0. 8 times 0 is 0 plus 6. We have 0 plus 0 plus 6, and that equals 6. All right. So notice that any term with a 0 in it basically goes away, becomes nothing.
Okay.
The y-intercept is an ordered pair, 0, 6.
Got it.
All right. So I'd like to give you one to try here. You're going to do this exact same thing. If you don't feel like talking, you can always put the answer in the chat here. But any questions on this before I go ahead
No.
and clear the screen here? All right. So let's say give you something like this: f of x equals 3x squared plus 4x. And I want you to find the y-intercept. Y-intercept, just like in the last problem here.
If it has an X, that means it cancels, right?
Goes away completely, yes.
So the y-intercept is 0.
It would be 0. F of 0 ends up being 3 times 0 squared plus 4 times 0, which is 0 plus 0 or 0. And you got it.
Okay.
All right.
Got
Next
it.
thing here to think about, to look at is other functions. Okay, so I could give you another function. I could say, okay, it's 3 absolute value x minus 1 minus 2. Okay, and I could ask you for the same thing. I'd say, what is the y-intercept? Okay, and it's the same thing. You got to put 0 in for x. The difference, though, with this problem is when you put 0 in, you have to sort of do some stuff. You have to subtract 1, then take the absolute value, then multiply by 3, and then subtract by 2. So there's like a few steps there. It's not the same as this problem where you're like, all right, it's got an x gone, got an x gone, it's just 0.
Yeah.
So let's do that here. Let's find f of 0. So f of 0 is 3 absolute value 0 minus 1 minus 2. So inside parentheses, 0 minus 1 is minus 1. The absolute value of minus 1 is 1. 3 times 1 minus 2. This becomes 3 minus 2, which is 1. Now, you don't have to go through all the steps that I've gone through. I'm just showing them out to help you here. You're supposed to subtract from 1, 0, or 0. I'm sorry, subtract 1 from 0. You get a negative. The absolute value always returns a positive. Then you multiply, then you subtract, you get your final answer.
Okay.
Okay, but the y-intercept, generally is x is 0. X is 0. So here's
Okay.
one for you to try. Let's have you try this one here. F of x, 2 absolute value x plus 1 minus 4. I want you to find the y-intercept, please.
Would it just be 2
Nope.
or negative 2?
So why is it negative 2?
Because 2 times 1 is 2 minus negative 4.
Exactly, yes. So it would look like this 0 minus 2, like that. Really good. So the key thing here, the key thing that we're talking about right now is that the y-intercept, it doesn't matter what it is, it's when x is 0.
Okay.
Okay, so I can even give you something else, like, which appears to be totally unrelated, like 2x plus 3y equals 6. And I could similarly ask you for the y-intercept.
Yeah.
And like a parrot repeats, what you say. It's like, I want you to say, okay, the y-intercept means that x equals 0. You're putting 0 in for x. Okay. This time, 2 times 0 is 0. So that term goes away.
Okay.
Okay, and then you just have the 3y equals 6. So you're solving for y. Divide both sides by 3. Y equals 2.
Got it.
So it doesn't matter what we're doing. The y-intercept will always be this this path, this process here.
Okay.
All right. So it does appear you're gonna have to do some type of factoring on your final exam here. So let's look at something like this. It's not crazy bad. Let's go x squared plus 5x plus 6 equals 0. This time, actually, let me rewrite this. This is f of x. This time we want to find the x-intercept. Okay, so this is different. This is where it crosses the x-axis.
Okay.
It's where y equals 0. So kind of big, big difference here. To do this, you set the function equal to 0, not x, the function, like the whole thing, x squared plus 5x plus 6, you set that equal to 0.
Okay.
And this is where you got to do some type of factoring that you've learned over the course of the school year.
Yeah.
And I'll give you some reminders here, but does this at all look familiar to you about how to factor this, or completely?
A little bit, yeah.
Okay, if you're looking for two numbers that multiply to 6, but add to 5.
Two numbers that multiply to 6 and they add to 5.
Yeah,
But 3 and 2.
3 and 2. So this becomes x plus 3, x plus 2 equals 0.
Okay.
From here, you have to set each of those factors equal to 0.
Okay.
And then you have to solve those for x. Can you give me the x-intercepts? Can you give me the values of x that make these 0?
The value of the x-intercepts
Yes. What makes these equal to 0? What values of x?
is 0 or
So
subtracting.
you got to get x by itself. How do you undo the plus 3?
You subtract 3.
Okay. So what does x equal after you subtract 3?
-3.
Okay. And how about the other one here?
-2.
-2. Good. Okay. All right. So let's do another one kind of like that. Let's say the function is x squared plus 7x plus 12. And again, we want to find the x-intercepts. So just like the last problem, what that means is you're setting the entire function equal to 0.
Okay.
Okay. And then you've been solving problems like this for a while now. A lot of students do it, since January. You did your share of them. You're finding two numbers that multiply to 12, but add to 7.
4 and 3.
4 and 3. So this becomes x plus 4, x plus 3 equal to 0.
Okay.
What did we do in the last problem once we got it down to the form?
Subtract 4, subtract 3.
Right. So you set them both equal to 0. And then you still solve for x. So what are the two x values?
Well, -4 and -3.
Good. All right. Now there's other types of factoring that you might see. Okay, and that's something we've been talking about here for a while. This is just one of many types. So here's another type of function that you might see. Let's say it's x squared minus 9 equals 0. Okay, because we want to find the x-intercepts again. All right, so what's different about this problem is that there's no middle term. It's just x squared minus 9. So when you set this equal to 0, x squared minus 9 equal to 0, This is now difference of squares. Do you remember that at all from earlier in the year?
A little bit, yeah.
Okay, so there's two things that multiply together and it's based on this value right here, this 9. What number, kind of like the last problem, what number when you square it gets back to 9?
3.
3. So this becomes x minus 3, x plus 3.
Okay.
So if you were to FOIL this, you would get back to the previous line, believe it or not. And just like the last problem, you set each of these equal to 0.
Yeah.
What are the two x values?
Positive 3 and negative 3.
Good.
Yeah.
All right, so this is difference of squares. So let me give you one to try here. Let's say f of x equals x squared minus 25. I want you to find the x-intercept, please. Basically the same thing as the last problem, just with different numbers here.
Can you just guide me through it while I'm doing it too?
Well, I'll go back and show you this. You set it equal to 0, and then you have to apply this difference of squares.
Okay, I got this one. It would be, you can go back down.
Okay.
It would be x plus 5 and x minus 5.
Really good. Yep.
That
Okay, and
is
then
to 0, right? Or whatever.
yep, good.
And it would turn out as x equals negative 5 and x equals positive 5.
All right. Okay, so quick review. We've talked about y-intercepts.
Yeah.
That was the first thing we talked about. That's when you put x equal to 0. X-intercepts are when you set y equal to 0. Okay, and they're very different. Y or even f of x equal to 0. They're very different. One is actually putting 0 in for x.
Yeah.
And the one on the right here is to set the equation, function, whatever, equal to 0. Okay, so very different. But I need you to have this down. Like, I don't know if you need to stare at it for 30 seconds and say, okay, I got it. But I want to kind of do rapid fire here where we go back and forth and you solve some problems.
Okay.
And what I don't want to have happen is I ask you for the y-intercept and you do the thing on the right, or if I ask for the x-intercept, you do the thing on the left.
Okay. I got this one.
You got it?
Yeah.
All right, here we go. So let's say f of x equals 2x minus 5. I want you to first find the y-intercept of this.
It would be, I don't even, I'm sorry, I'm like really slow today. But
So like I said, I want you to be able to tell me which one that you're doing. Are you setting x equal to 0
yeah, x equals 0.
or y equal to 0? And you said it correctly. Okay, so you're putting 0 in for x. You have to find f of 0.
Would that be a number that multiplies into, no, that's not.
You're putting 0 in for x.
2 times 0 minus 5, would that be it?
Yep, that's correct.
So
What does that become?
negative 5.
Good. So if we wanted as an ordered pair, it'd be 0 comma negative 5. That's where the 0 comes from. You're saying x is 0, and then the output, the result is the y value. Y is minus 5.
Okay.
Okay. All right. So now let's do another one here. Let's go f of x equals 2x squared. Actually, let's not do that. Let's go x squared minus 16. Okay. And this time we want to find the x-intercept.
That would be, would it be set to y equals 0?
Yes, you set the whole thing equal to 0.
Would it just end up being -16?
Nope. Let's go back and look. We did two problems like this. We did this first problem, x squared minus 9 equals 0.
Oh, yeah, yeah, I
Okay.
see now. It's these two.
Same thing down here.
It would be x minus 4, x plus 4.
Good.
And it would end up being x equals 4 and x equals -4.
Okay. And if we were to write these as ordered pairs, it'd be 4, 0 and
And
minus
0.
4,
Yeah.
good. All right. So here's a new problem for us to look at, and then we'll maybe transition to something else. X squared plus 8x plus 15. Let's first determine the y-intercept. Y-intercept.
X equals 0.
Okay, that's true. What is the y value?
15.
Yes, so it'd be 0, 15. Very good. Now let's do the same thing for the x-intercepts.
You'd set it to y equals 0, right?
Good. So you're setting the whole thing equal to 0.
And then it would be 5 and 3.
Okay, those are the factors. X plus 5, x plus 3.
And then it would just be, it would subtract, right, on each side.
Okay, so give me the final values for x.
X equals -5, x equals -3.
Very good. All right, so let's move to something else here, kind of related. I guess we'll talk a little bit about domain and range. So here is a graph on the left and the graph on the right here. So the let me just graph something here. So this first one has a vertex at -3, -2. And then this one on the right has a vertex. We'll go over here where it opens down. Got a vertex at 4, 3. The domain for both of these is all real numbers.
Okay.
Assume you've seen that. The range though is -2 to infinity for the one on the left, and for the one on the right, it's -infinity to +3.
Okay.
I want you to stare at the graphs real hard and the range real hard and tell me which number in the graph is being used, or you can say which one is not being used.
Okay.
It's the same in both. Like which one's kind of a distracting value, which one do you actually need?
Would you need the one on the left?
So where does this -2 come from in this point here? +2, actually, I messed that up.
I'm not really sure.
Which one is it? Is it the X or the Y?
The y.
The Y. How about the 3? Where does it come from?
The y.
So do you need the X?
Yeah.
No, you don't. It doesn't help you.
Yeah.
Okay. Now, the one on the left here says 2 to infinity. It means it starts at 2 and goes up to infinity.
Yeah. Correct.
The one on the left here starts at -infinity, but goes up to 3.
Yeah.
Okay. So I need you to kind of look real hard and say, okay, I kind of see this one on the left, see this one on the right. Because what I'm going to do is give you some graphs and give you the two possible ranges. And I want you to tell me the right answer. So the one that opens up starts with the number on the vertex. The one that opens down ends with the number on the vertex.
Okay.
So this is a not a difficult skill, but again, there's two possibilities, right? So you just gotta remember this here. So here's a graph, and we'll go. This is -3, 1. is the range, which of the following is the range here? Let's go minus infinity to -3, minus infinity to 1. Let's go -3 to infinity. Let's go 1 to infinity. So which of these is correct? And if you're not sure, there should be 2 you can eliminate right away because they have the wrong value in it altogether.
Yeah, the ones.
The ones are the ones, the 2 with the ones, are they to eliminate or to keep?
To keep.
To keep. So the one in this X value is irrelevant. So those first 2 are not useful.
Yeah.
So it depends here whether it's starting down and going up or whether it's starting at the vertex and going up to infinity, which is it, the one on the left or the one on the right?
The one on the right.
The one on the right says you could be a value like 10. You can see the graph up here at 10.
The one on the left.
Yeah, it's one left. So I just when something like this happens, I know you're just guessing because there is an example here that's really similar. This means min to max. Okay, it's like, where does it start? Goes down all the way down, goes down forever. Where does it stop? It stops at 3.
Okay.
All right. So if you want to take away anything from this part of the lesson, it's that the range excludes the X value of the vertex. You don't care about the X value, just the Y value, just the Y value when you're doing the vertex there.
Got it.
All right. Well, I think we've done all we can today.
Yeah.
So we got another lesson scheduled for